All right, in today's video reference, we're going to learn how to estimate square roots. But instead of guess and check, we're going to do, I call it differences and divide type of method. So if you look here, you get the square root of 27. So step one, just like when we were estimating, you determine the two consecutive whole numbers that the square root of 27 is behind. Between. So square root of 27, what two perfect squares are between? Raise your hand. What's the lower perfect square? Square root of 25. And what's the bigger perfect square? Square root of 36. So now you know that it is between 5 and 6. So in the other lesson, we would just then go ahead and say, all right, this is definitely closer to 5, and try 5.1, 5.2, 5.3. times itself until we get as close to 27 as possible. But now we're going to do something a little different. So if you think of a fraction as the bottom is your whole and the top is your part, okay? So really at the bottom, you want to find the difference between the bigger and the lower perfect square. That's your entire distance. So if you did that, you're the square root of 36 minus the square root of 25 is how many square roots away? The whole distance away is 11 square roots. Now to get the part, what you're going to do is take the lower, take the actual irrational number, so that was 27, and then subtract the lower perfect square, which was 25. So it's only 2 away. So again, if you think of this on a number line, over here you have square root of 25, square root of 36, and right here you have the square root of 27. So really what you're dividing when your fraction is like this little 2 divided by the whole distance apart is 11 apart. So then what you have to do, you know your answer is going to be 5, and then the fraction's 2 11ths, but we need to change that to a decimal. So does anyone remember what goes on the inside and the outside when you do 2 divided by 11? You get 2 on the inside, 11 on the outside. And then you have to add a decimal and a bunch of zeros. And 11 goes into 20 one time, and then you're subtracting, and you can pop the decimal there. Left with 9, and then a 0, and then 8, and then 88, and then 2 and 0. And it's going to repeat over and over and over again. And again, the number that goes up here in the ones digit is the 5, because it's closer to 5. So now your approximation is 5.18 repeating, or 5.2. And again, if we did guess and check, we would end up coming to 5.2. This is less guess and check, and it's more about, again, taking the whole at the bottom, the difference between both perfect squares, divide, and then on the numerator is just the smaller distance between the lower perfect square and the lower perfect square and the irrational. So I hope that helps. If you turn the page to page 10, let me set this part up for you. So, and then we can pause the video here. So square root of 135. What's the lower perfect square? That's definitely 121. The higher perfect square is 144. So what two numbers is it between? 11 and 12. So now at the bottom, can someone tell me what we're going to subtract for the denominator? The whole distance is what? 144 minus 121. So that's going to be 10, 20, 23, I believe. Hopefully I'm right. And then the top, what are we going to subtract for the little difference? Yeah, it's going to be 135 minus 121. So then that would be 14, 23s. And so the answer is going to be 11. And then whatever we can change 14/23s to as a decimal. So we do 14 on the inside, 23 on the outside. Again, this whole number here is going to be 11 and change. And then we could just I'll pause the video here and you can try to continue to change that to a decimal.